Okay, this video is to go over those 6 problems that were up on the whiteboard as a warm-up the day that you took your proof quiz. So you had 30 minutes to work on these problems on your own and come ask questions and check your work. I wanted to make a video where you could see me doing the problems and talking about the problems, which means you need to be listening to what I'm saying right now so that you understand my thought process. For those of you who are coming up and being like, well, I don't understand how you know to do that. It's not that I know to do that, it's just that I have ideas, I have things in my toolkit when I see certain proofs. So let's talk about these. So these were the 6, write them down really quick. There'll be 1 on each page as I go, so pause it if you need to. So number 1. Okay, first thing, when I see this, there is so many trig functions on the left-hand side, but there is only a single trig function on the right-hand side. So when I see all sorts of trigs, like more than 2 trigs in one side of my equation, I'm going to turn them all to sines and cosines. So not necessarily, so I know tangent is 1 over cotangent, but that's not always helpful. We want to turn them all to sines and cosines. So go through and do that. Pause it if you know how, go through and do that. Secant is 1 over cosine. Sine is already in sine form. It's sines and cosines that we're going for. And tangent is sine over cosine. Make sure you're writing the theta every time. I am fine if you say it cosine, but you need to be writing down the theta. Okay, now that I've done that, I used red unfortunately, so I guess I'll switch. I am going to do fraction busters to get rid of all those fractions. So if you look at your little denominators, this is over 1, this is over 1. Cosine is your common denominator. But you have 4 terms, so each of your 4 terms are separated by plus or minus signs, gets multiplied by a cosine theta. When you do that, the first fraction crosses out. You just get 1 left over. 1 times cosine is cosine. Nothing crosses out, so cosine theta, sine theta. Plus, and the cosines cross out here, and you're just left with sine theta. Make sure you are bringing down the other side every time. Now when I look at it, I see that the bottom has a common denominator. So there's a sine, you can't see that color. There's a sine theta here and here that I can factor out. So I'm going to leave the top alone. Factor out sine theta as a GCF. Go ahead and do that. Divide by sine and you have cosine. Divide by sine and you still have plus 1. Well, addition, 1 plus cosine and cosine plus 1 are the same things. So those cross out on my next step. 1 on top over sine theta, and that is cosecant. Cosecant theta equals cosecant theta. There are plenty of other ways you could have done it. This is how I did it. Okay, number 2. When I look at number 2, the denominator on the left side is almost an identity. Your Pythagorean identities are 1 minus sine squared theta. So since it's so close to being an identity, I'm going to multiply by the conjugate, 1 plus sine theta, on top and bottom, only on the one side of my equation. When I do that, I need to distribute on top. So cosine times 1 is cosine, plus cosine times sine is cosine theta, sine theta, over. And on the bottom, you could do FOIL or an area diagram, or you could just get used to difference of squares. 1 plus sine times 1 minus sine is going to be 1 minus sine squared theta. Bring down the other side. The whole reason I did that was because this is an identity. So in my next step, I will replace the bottom with its identity. Cosine squared theta. Okay, then on your quizzes, I saw a lot of you doing this. I'm going to make this dark red. A lot of you went, let me write it out, sorry. A lot of you went cosine, cosine, cosine. While that may be what happens mathematically, that is not how it happens. So you either need to show me GCF, that's how I do it, which is obviously an acceptable way to do it, So factor out the cosine, bring down the other side. Then a single cosine crosses out with a single cosine. We only divide one thing. So then you are left with 1 plus sine theta over cosine theta, which was our goal. Oops. The other legal option that some of you did from this step was split it into two fractions. Cosine theta over cosine squared theta plus cosine theta sine theta over cosine squared theta. One of them crosses out here, 1 over cosine. One of them crosses out here, plus sine over cosine. Since they're both over the same thing, you would end up getting that one back again, but it did take 2 steps, like 1 extra step than mine. Either way, make sure you are not showing it this way. We do not cross out more than one thing when we are dividing. One number over one number crosses out at a time. Okay, no, I don't put my little check mark. We're good. Number 3. So when I look at number 3, I definitely think the side that has a bigger exponent is the more complicated side. I also notice that the bottom is almost a Pythagorean identity, right? 1 minus cosine squared is the identity, so multiply by the conjugate. If you haven't yet, pause the video and see what you get when you multiply by the conjugate. Distribute on top. Difference of squares on the bottom. Bring down the other side. I say it every single time, and some of you are going to be shocked when you lose points on test day for not bringing down the other side. The reason we did that was the bottom is an identity, sine squared theta. We're kind of in the same spot as before with that GCF idea, but in this case, because the right-hand side has 2 separate terms separated by a plus sign, I am going to separate mine. The denominator is a single term, so I'm allowed to separate it as 2 sine cubed over sine squared. Problem says plus, and separate this one, 2 sine cubed cosine over sine squared. Bring down the other side. Then reduce. 3 of these go away. Sorry, 2 of those go away to leave me with 2 sine theta. 2 of those go away to leave me with 2 sine theta cosine theta, which is what I was trying to prove. Okay, looking at number 4 and remembering what I said, what do you think we're going to do to this one? So I see 1, 2, 3, 4, 5, 6 different trig functions in this one problem. I don't like that. Everything to sines and cosines. Cotangent, I know it's 1 over tangent, but we want sines and cosines. That's cosine over sine. Okay, get rid of all those fractions. Denominators, sine, cosine. So 1 of each. Sine theta, cosine theta. Sine theta, cosine theta. Sine theta, cosine theta. Sine theta, cosine theta. Pay attention to the bottom. The bottom is sine for this one, so I'm left with cosine cubed. 3 cosines. Minus. The bottom is cosine, I'm left with sine cubed. Over. The bottom is sine, I'm left with cosine. Minus. The bottom is cosine, I'm left with sine. I don't know why I switched to purple and kept it, but we'll just keep going with it. Okay, now you need to be able to recognize factoring it when it shows up. So cubed minus cubed, this is a difference of cube factoring problem. So cube root of cosine is, so cube root of cosine cubed is cosine. SOAP, same symbol. Cube root of sine cube is sine. Then at your first term squared, cosine squared theta, opposite symbol plus. The two of them multiplied together, always positive, plus the last term squared. And I did not change the bottom. And it's still a proof. Okay, now these two parentheses match perfectly, cosine, sine, and in this parenthesis you have an identity. There's a little bit of distance between them, but you can do that identity and a division at the same time. Cosine squared minus sine squared, or plus sine squared, is just 1, and the problem says plus cosine theta sine theta, which is the same thing as 1 plus sine theta cosine theta. Multiplication, it doesn't matter what order you multiply. And we're done. Okay, number 5. So on this problem, when I look at it, I notice that the left has two terms, right? They're separated by a plus sign. But the right side only has one term. So I'm going to need to merge these terms together. The only way I can merge terms together is to make a common denominator. So you need to multiply by what's missing. So cosine 1 plus sine is going to be our common. In fact, let's just write that down. This is why we did rational expressions last chapter. A cosine x and a 1 plus sine x is our common denominator. Let's bring this down before we forget. So the left side is missing 1 plus sine on top and bottom, but I already wrote it on the bottom. So I'll distribute sine x plus sine squared x. Problem says plus. The right side is missing the cosine on top and bottom to make the bottoms match, which is cosine squared. Now what do you have? Well, now you have sine squared plus cosine squared, which is just 1. Remember, the order of addition does not matter, so sine plus 1 over 1 plus sine is the same thing. The whole parentheses matches. We're not killing any kittens. You're left with 1 over cosine. 1 over cosine is secant. Number 6. Okay, basically at that same spot on number 4, where you need to recognize factoring, especially cubic factoring. Number 6, the top is a cubic factoring problem. See if you can factor that. Pause the video. Same symbol. Opposite symbol. Always positive. Don't change anything else. Top parenthesis matches the bottom perfectly. And sine squared plus cosine squared is an identity. That's 1. So you're left with 1 minus sine x cosine x, which is what we wanted to prove. Okay, this was your quiz. Let's go over your quiz really quickly also. So there were 2 main ways I saw most of you doing it, which was great. This is why on the test I don't really have a key. I just have to watch your work and see if it makes sense or not. So one thing some of you did was you noticed that the top was an identity. So some of you kept the 1, changed the top. Cosine squared is 1 minus sine squared. Then 1 minus sine squared, that's a factoring problem. All of your identities somehow are a factoring problem also. That's a difference of squares. So that's 1 minus sine x times 1 plus sine x. Then 1 plus sine x crosses out with the 1 plus sine x on the bottom. And a lot of you got to here, and then some of you just faked it, or you went back and made that a plus, which it wasn't supposed to be. When there's a minus in front of a fraction, the minus goes to everything inside of there. So this becomes 1 minus 1 plus sine. 1 minus 1 obviously goes away, and you get sine x equals sine x. Okay, another thing that I saw you guys do, so I'm just going to start over here, is you multiply by the conjugate on the second fraction because you saw that 1 plus sign was almost an identity. So you multiplied top and bottom by 1 minus sign. So keep that 1 in the front. You don't even have to distribute in this case because of what's going to happen. So I'm going to leave it. Some of you did, which was fine. 1 minus sine squared x. You did that because that's an identity. Then your cosine squared's crossed out, and you were left with 1 minus parentheses, 1 minus sign again. Again, some of you faked it and just made that a plus as if it was supposed to be a plus the whole time. That's not how it happens. The minus gets distributed, and then 1 minus 1 is sine. Okay, so hopefully this gave you some methods to help you with your proofs, and I hope you guys are doing good.